8.1 distribution of water. Beautiful blue marble of planet Earth. Wonderful. Where is Earth's water? Elijah, where's Earth's water? What does it say? Read that paragraph for me.
Here's a photo of Earth. Here's a photo of Earth from space again. It's pretty easy to see where most of the Earth's water is in the oceans. Nearly all of Earth's water is in the seas, although it's extremely useful for ocean ecosystems.
Yeah, you can pronounce it ecosystems or ecosystems. Some people do that. I don't know why I say ecosystems too. Ecosystems sounds like it's like a ecosystem. Like there's no H is what I'm saying. It's just, go ahead.
It's not very useful for people.
Stop! What? What do you mean it's not very useful for people? It says, although the Earth's water being in the seas isn't, it's useful for ecosystems, it's not useful for people. Do we not use the oceans for anything? It says it's not very useful for people. Are you kidding me? Who wrote this dribble? How do we use the seawater? The water in the seas. How is it important to people? It says it's not very useful for us. Nobody? Go. Travel. Probably number one. I mean, other than pulling food out of the daggone sea, right? Don't we get food from the sea? Chicken from the sea? I mean, it says on the can, chicken of the sea. Just saying. It's tuna, right? It's a brand. Anybody like tuna fish sandwich? Anybody like how about a tuna steak? Anybody ever have a tuna steak? They make them, yeah. Anybody like tuna casserole? Okay, fine. How about salmon? Anybody like salmon? Go to a nice restaurant, they make some good salmon. I tell you what, I don't think I've ever had salmon a way I didn't like. Hello? Hi, Mr. I want my own conversation, and Mr. Me Too. I also want my own conversation. You ever have salmon at a restaurant? No? Do you not like salmon? Have you ever had salmon? He's never had salmon. It's terrible. Guys, do better in life. Have food, not just chicken nuggies. There is other food than chicken nuggies and mackey and cheesy. Okay, you laugh, but it's true. Some of you guys are sheltered. Oh my goodness. When you get an opportunity, have some real food. But yes, I love the answer, transportation. Lancet, I'm talking about you. I'm praising you right now. Good job. Didn't we do the tennis shoe thing the other day? Was that this class? Where we looked at our tennis shoes again, like where it come from? How much of our stuff comes to us via the ocean? Like on a cargo ship, goes across the daggone ocean to us. All right. So I think I made my point. Very useful to people. But it says, so where is the water that we can use, I guess, more easily, like to drink? Okay, fair. Couldn't we drink seawater?
Yeah.
How? I heard boil it, and then you capture the water vapor. It condenses, right? It's called distilling. You can distill the water, and that desalinates it, essentially. Yes?
Yeah.
Takes the salt out. You could run it through some kind of reverse osmosis machine or something that might be more expensive or more energy intensive. I don't know. But yeah, we can still use it in other ways too. Naval ships, where people are on those ships for a long period of time and they can't get resupply. I don't know if I'm not a Navy man, but I'm pretty sure most, decent sized Navy ships have desalination plants on board. Like all of them with nuclear reactors have a desalination plant on board because they got the power to run it, and they're literally floating on the water all the time. So they turn some of that salt water from the ocean into clean drinking water, water they can shower in and cook with and all that, okay? So where is Earth's fresh water? As seen below, only 3% of Earth's water is fresh. So let's look below. We've got total water on Earth. And it's got this gigantic spigot coming out of the fishbowl Earth. 97% of all the water on Earth is in our oceans. That's not surprising, is it? Is that surprising? No, it shouldn't be surprising. So that's the first container they fill. They say 97% of all of it is oceans. And then it's got like this side tap over here. And it says, okay, there's 3%. So you got 97. The other 3 is fresh water. It's in this little cup. And then they break it down further and they say, all right, well, the ice caps and glaciers make up 70% of that fresh water. So 70% of 3%, which is like not much, right? And then we have groundwater is 30% almost. Accessible fresh water, 1%. That 1% looks like this little measuring spoon, tablespoon, teaspoon, whatever the heck it is. You guys see that? That is the easily accessible of the fresh water. So that 1% is broken down. 52% of that 1% is in lakes. 38% is in moisture in the soil. 8% is in the air as water vapor. 1% is in the rivers. 1% is water and living things. I like this one, the rivers. Because if you take all of the water on Earth, okay, all of the water on Earth, 1% of 3% is river water. Anybody ever looked at the Ohio? Right here next to Louisville, right? The Ohio. It's a big river. Goes for a long ways. The Mississippi, the Nile. Back at where we're reading. We're not there yet. We're here. Fresh water is water that contains little or no dissolved salt. Has anybody ever gotten seawater in their mouth? Close your computers. Again, good grief. What's it taste like? It's like if you took a glass of water and poured like 2 tablespoons of water and mixed it up. Yeah, it's pretty salty. And it's got that little something extra. It's not just salt water. It's got that little something makes it perfect. Just the right amount of pee and poo from all the fish. Right? And the little kids, like if you're at the beach, you know the little kids are going pee in there. I mean, some of the adults are probably doing it too. I'm just saying. So if you get some of that in your mouth, like that's just salt water. Well, it's got that little something extra. Okay. Most fresh water is frozen in ice caps and glaciers. Glaciers cover the peaks of some tall mountains. You guys knew that, right? Okay. For example, the Cascades in the Northwest and the Alps in Europe are capped with ice. Ice caps cover vast areas of Antarctica and Greenland. Chunks of ice frequently break off ice caps. They form icebergs that float in the oceans. There was a story, I don't remember the details, but apparently there was this big, powerful, rich leader or something that wanted ice for like a party, or the details of the story, or I don't remember. You ever hear this one? Was it maybe one that we learned in 7th grade? Like, because it was in the Middle East. I want to say it was the Middle East, and they wanted an iceberg brought, and like they'd pay them for whatever was left. I don't remember the details. You can Google that one. It might be a fun Googled story. All right, guys, this is almost done. Almost done. Only a tiny fraction of Earth's fresh water is liquid at the surface. Most liquid fresh water is under the ground in layers of rock. Of fresh water on the surface, the majority occurs in lakes and soil. What percentage of fresh water on the surface is found in living things? We just go back up here and be like, oh, water in living things. 1% of 1% of 3%. Whoa, that's not much. Water can remain in a particular location for a long time. This is known as a reservoir. Reservoirs for water include oceans, glaciers, ponds, or even the atmosphere, where it's stored as water vapor, right, Elijah? Holy mackerel. I've used your name like 10 times today. The people in the YouTube verse will be like, man, that Elijah kid needed to be written up. A water molecule may pass through a reservoir very quickly or may remain for much longer. The amount of time a molecule stays in a reservoir is known as its residence time. Its residence time. Not its resistance time, its residence time. As in like that water molecule is a resident of the ocean. Like it took out a 60-day lease on an apartment in the ocean or something. I don't know. Does that make sense? The amount of time the water molecule stays in one of the reservoirs is the residence time. Water in the ocean, residence time on average is 3,200 years, which I was kind of surprised it's that few. But, you know, like evaporation goes up into the clouds, comes back down back on the oceans or maybe on land. I suppose the longest term reservoir would probably be glaciers or ice, right? Maybe? Because they could stay locked up frozen for hundreds of thousands of years, depending on where it goes. Summary. Of Earth's water, 97% is in the oceans. Of the remaining 3%, much is trapped in ice and glaciers. A substance is stored in a reservoir. In this case, we're talking about water. The amount of time it stays in that reservoir is residence time. All right, this video angered me because I started watching it and the first like 3 minutes were explaining her educational philosophy. Like, keep that in college. All right, you are officially assigned in 3, 2, 1. Go. All right.